Hello, students. Once again, you're welcome to Wisdom University. Today, what we have is we're looking at chapter 8, part 6. Okay, chapter 8, part 6, which is troubleshooting the switch interface. So today we want to look at how to troubleshoot the switch interface. Remember, we've in chapter 7, 5, 4 or 5, we've looked at troubleshooting the router interface. So this has a similitude with troubleshooting the switch. Troubleshooting router has a similitude with troubleshooting the switch interface as well. So without much ado, let's begin. Okay. Now what we're looking at today is to look how to troubleshoot another type of network equipment called the switch. We are looking at how to troubleshoot the switch. In the previous case, in the previous chapter, we looked at troubleshooting the router interface, which is also a different kind of network equipment. Now, a switch is another different equipment. So what we're looking at in this chapter is to look at how to troubleshoot the switch interface. Now, troubleshooting concept presented for router is similar to the one for switch. Okay, we apply the same concept to troubleshooting switches. So if you already understood how to troubleshoot a router, we're also going to do similarity on troubleshooting the switches. Is that okay? So we're going to do similarity in how we troubleshoot the switch. So what you've learned in troubleshooting router will be playing in these same chapters, or similar to what is playing in this chapter on troubleshooting the router, troubleshooting the switch interface. Now, we say since they are similar, one should verify the switch configuration to make sure that it's correct, and we should also verify all the interfaces, the switch interfaces, to make sure that they are up and they're operating in the right mode. So we need to verify what? The configuration. There are two things we first of all have to deal with. We have to verify the switch configuration, and then we have to verify the switch interfaces. So we have to verify and ensure both the switch configurations and the switch interfaces are running in the right mode. Okay, now how do we do that? How do we verify all of this, both the switch configuration and the switch interfaces? How do we carry out this verification? To do that, we have to understand and know the command that we always write on the interface, or on the interface, to show us what we have with regards to the configurations, and with regards to the switch configuration, and with regards to the switch interfaces. And that command is no other than show IP interface brief. Show IP interface brief. Now this command helps to display what we have. Show IP interface brief. It will run the brief history of the switch, both the configurations and the interfaces. Okay, it will show both the configuration and the interfaces on the switch that has been done on the switch. Now, so this is what we need to know. We need to know this command, and we can use it to check the status of the interfaces on the router and also on the switch. Now, the same command can also be used on the switch. Remember, this command that we've talked about, we used it for router to show all the things that we have on the router interfaces. So the same command we run for checking the switch. Okay, we use this show IP interface brief command also for the switch. Now the output of the command will show the status of the physical interface as well as the VLAN interface. So this one will show us the status of the physical interfaces that we have on the switch, and the VLAN, the virtual local area network interfaces, okay, that are configured on the switch. Okay, now this is the application, how to do this, or what shows when we type this command on our interface. Now we say the following shows that the VLAN one is configured and it's up and operational. Okay, what we go to test, we type this. If you're using it for switch, you must write switch A. If it's a switch A, if it's switch 1, you write switch 1. If it's switch B, you write switch B. Whatever. So if you're using it for switch, you must remember when we're using this show IP interface brief for router, we write router hashtag, So since we are doing switch, we write switch A. You be specific, because in the network, in the campus network, there could be a good number of switches. You may have switch A, B, C, D, E, F, like that. So which of the switch do you want to see the interfaces and the configurations? Which of the switch do we want to see the interfaces, their configurations, their status, their protocols, their IP address, and all of this is. So which switch? So you must designate the switches. Remember, when the switch were configured, they were given names. Switches were given names: switch A, switch B, switch C, switch D. So when you type which switch, if it's switch C, you write switch C hashtag show IP interface brief. Okay? If it's switch A, you say switch A hashtag show IP interface brief. So when you do that, it will display both the excuse me. To display both the interface, the IP address, the status, the status, whether it's okay or not okay, and the protocol. So all of this will display. For example, you can see the interface. You have the VLAN 1. And in VLAN 1, Virtual Local Area Network 1, for this switch, it has these interfaces. Fast Ethernet 0/1, Fast Ethernet 0/2 interface, Fast Ethernet 0/3, Fast Ethernet 0/4, Fast Ethernet 0/5. So these are all the interfaces that are displayed. You can see the VLAN, the IP address for the VLAN, because that's the one that have IP address. Remember, for the interfaces and the ports, we didn't assign IP address for those ones. But for the VLAN, it has its own IP address, which is 10.123.124.2. So it has been assigned a dynamic IP address. And then the status, whether it's the method status, which method was used, and what is the status. Up means it's good, it's running. Yes means it's okay. Okay, NV RAM up, meaning is running. Okay, and the protocol is up, meaning the protocol is also running. So you look at the Fast Ethernet 0/2 unassigned. So Fast Ethernet, this interface, Fast Ethernet 0/1, 0/2, 0/3, 0/4, none of them has an IP address. They are unassigned. Okay, but they are up and running. Okay, and you can see their protocol, except this one. So this one is down, meaning it's not assigned, it's not connected, it's down, the protocol is down. So you can fix the protocol. So you can see you've troubleshooted, you see where the problem is. This interface is not working, so you can fix it back. And we're going to describe that, how to do that. Now, the next one is the show interface status. Because it's not only this command that we use, the show IP interface brief, we also have other command that shows the status of the interfaces. Now, what you might find that the command show IP interface brief does not offer enough layer 2 or layer 1 information. It's only showing you the protocol, and it's not giving you details information on the different layer 1 switch. It's just showing you the slots, the ports, but it's not giving the details information. So as a result, we need another command that can show us more of the information. So another useful command for displaying the status of the switch interface is what we call the show interface status. So this is the second command that we are talking about, or we've talked about now. Okay, the first one was show interface brief. Okay, that's the first command. The first command was show IP interface brief. The second command is show interface status. Show interface status. So when we type this, remember, if you want to type that, you must say what your type is. You write switch A hashtag. This command is just the driver. So, but you must designate or assign a dynamic driver. So you say switch A hashtag show interface status. You see, it shows you all the status, the speed, the duplex, the type that is used. Okay, the type of duplex that is used, and the mode, whether they are auto-negotiated or so, the interface, the VLAN interfaces, the status, whether they're connected or not connected, what type of building is the switch in, the switch is on which building, and so on and so forth. And then the ports, the port designations. are all displayed when you type this show interface status command on your system to display the switch details. So you can see this shows a lot details compared to the show IP interface brief command. Show IP interface brief command was not showing all the details, all the status. But when you run another command called show interface status, it shows you the following. For example, these are all Cisco switch, Cisco switch. Say, if you type on switch the interface of the Cisco switch, you say shows the output from a Cisco switch. For example, you type switch A hashtag show interface status. You type this command. If you run this command, this is what you get. All of this will be displayed. All of this will be displayed. You see the port, the name, the status, the VLAN, the duplex, the speed, the type, and all of this. See the ports, giga interface 1/0/1, giga interface 0/2, giga interface 0/3, giga interface 0/4, giga interface 0/5, and you can see the name may field. This is in the may field, and this is the build A, build B, build C. These are where these switches, interface are located or going to. Then the status, they connected. These two not connected. And then you can see the VLAN, virtual local area network. We've described the VLAN in one of our previous sections. And then we have VLAN 1, VLAN 2, VLAN 2, VLAN 1, VLAN 1, VLAN 1. Okay. Then the duplex, whether full duplex or half duplex. This one is a full, a mini full duplex, a full duplex, a full duplex, full duplex. This one is auto negotiated. Actually, all of them are auto-negotiated, okay? They're usually auto-negotiation. We'll describe auto-negotiation in one of our previous sections. Okay, now let's, the speed, a 1000 megabit per second. 1000 megabit per second, 1000 megabit, auto. So, the type, 1000 base LX. LS is a single mode. SX is a multi-mode. So, this is a multi-mode. But this first one is a single mode, 1000 speed single mode. Okay, so now here is the description, further description. We say what you have here shows the status of the gigabit interfaces from 0/1 to 0/6, where only the gigabit interface 0/1 to 0/4 they have connection. If you look at the interfaces that have connection, is here. All these ones, they have connections 0/1 to 0/4 only. Okay, these are the ports with connection 0/1, 0/2, 0/3, 0/4. All these ones they are connected. You can see the status, they're connected. But 0/5 and 0/6 they are not connected. Okay, they are not connected, and because they are not connected, you will not know what is their speed, and you will not know what is their type, which type of the mode of duplex they are using. So you would know because they are not connected. Is that okay? Now all the ports are configured to auto-negotiated. Yes, all ports are configured auto-negotiated. We've described auto-negotiation, where two interfaces or two devices on a network, okay, communicate first before talk to themselves, accept what they have. This one advertises what it has. The switch advertises what it has, and then probably the computer that matches that capacity of the speed tells the switch, okay, I'm ready, I have this, I can support it. So when they can support both of them, both themselves, then they communicate and then they transmit. So that's auto negotiation. We've described this in one of our previous sections. Now all the active ports are connected at 1 gigabit per second full duplex. Yeah, why is it 1 gigabit? Because it's 1000 megabit. 1000 megabit is 1 gigabit. Okay, remember this. 1000 megabit per second is equal to 1 gig. 1000 mega is equal to 1 gig. So they are all running at 1 gigabit per second full duplex mode. Like I said earlier, they are connected and they are running at full duplex mode. Yeah, full duplex. All of them, they're running at full duplex mode. Is that okay? Now, we say the physical connection on the gigabit interface 0/1 is 1000 base, that's the physical connection on the interface. On 0/1 is 1000 base LX. 1000 base LX, okay, which shows that it's a single mode fiber type of connection. It's a single mode fiber connection. LX is a single mode fiber connection, okay. SX is a double mode, okay. Then the rest of the active ports are using multi-mode fiber type connectors. The SX, all these XX, they're multi-mode. These are multi-modes. 1000 base SX is a multi-mode, but 1000 base LX is a single mode fiber. So that's what it means. It's about the fiber connection, single mode and multi-mode fiber connections. Okay, the type of mode that is being used. Is that okay? That's what this displays. So now let's move on. Still on, we're showing the show interface status. You know, the show interface status shows most of the things that you need to see. Now the gigabit interface 0/1 to 0/4, 1 and 4, they're connected to what? VLAN 1. Look at it. This one, giga interface 0/1 and giga interface 0/4, they're both connected to VLAN 1. The interface for the VLAN, virtual local area network, is VLAN 1. Both of them. Okay? They're both connected to VLAN 1. 0/1 and 0/4, they're both connected to VLAN 1, the interface. Okay? While the gigabit interface 0/2 and 0/3, they're members of the VLAN 2. See 0/3, maybe we use a different color, right? To show this. No. Okay, let's move on. Okay. Yeah, which color? Let's use green. Okay. For the 0/3, look at it. 0/2, giga interface 0/2 and 0/3, they are connected to what? Which interface of the VLAN? They are connected to VLAN 2. They are connected to VLAN 2. So these two interfaces, giga interface 0/2 and 0/3, they both connected to VLAN 2, while giga interface 0/1, 0/4, they are connected to VLAN 1. Both of them are connected to VLAN 1. Okay? Now, since the gigabit interface 0/5 and 0/6, they're not used, you can see, they're not used. They're not connected. Means you can see their status. Giga interface 0/5 and 0/6, they're not used. They're not connected and they're not used. So their status are shown as not connected because they're not being used right now. Since they're not being used, so their status will be showing as not connected. I think we use blue in this one. Their status will be showing as not connected. This one. Okay. Despite we designate it to VLAN 1, that we designate both of them to VLAN 1, they are not being used at the moment. So since they are not being used, they will be not connected. And if they are not connected, what will happen to their fiber mode connection? It will be unknown. You will know which fiber mode connection is applicable. So the connector, the fiber mode connectors will be showing unknown. Because they are not connected. Okay. Now let's move on. Still on this, we say the gigabit interface 1 and 4, 0/1 and 0/4, this first one, you know, we're using red for this one. 0/1 and 0/4, this one. Gigabit interface 0/1 and gigabit interface 0/4, you can see what is happening to them. They configure to be members of the VLAN 1, which we've already itemized. We've said this. They're configured to be member of the VLAN 1. They're configured to the member of VLAN 1. Okay, and while gigabit interface 2 and 3, they are connected to VLAN 2. 2 and 3, they are connected to VLAN 2. So this gigabit interface, I think we've itemized this previously. Okay, let's group them together since they are next to each other. They are connected to VLAN 2, both of them. gigabit 2 interface 0/2 and 0/3, they are connected to VLAN 2. Since the gigabit interface 5 and 6 are not used, their status is shown as what? Not connected. Their status is shown as not connected. Look at it. This gigabit 5 and 6, their status is what? Not connect. That's it. And then the fiber mode type, is unknown. We won't know because it's not connected. We can't know that. Okay? Remain unknown. Okay, now let's move on to show interface status. Still on show interface status, what the advantage is, what we get, or what is we get from this. We say the duplex and the speeds are good information when troubleshooting performance issue. So when you're troubleshooting a switch, one of the things you look out for is the duplex. Look at the duplex 6, the duplex and the speed. They are good things to look out for. See, all these ones are one of the good things to look out for when you're troubleshooting the duplex and the speed and the type of connector, fiber connector that is used. These are good. They are good what? Well, let's use the red highlighter. So we say the duplex, anytime you are troubleshooting a switch, you look out for, that's why you need the show interface status, because this command, show interface status, shows the speed, show the duplex, show the optical fiber type connectors that you're using, and show the VLAN interfaces, the ports, and all the interfaces that are present, the status of the connections, all of this. So we say the duplex and the speed and the fiber type, they are good information when you troubleshoot a performance issue when it comes to switches. Is that okay? Now, when the reported duplex or speed does not match with the network interface card, this NIC is network interface card. So when your duplex or speed does not match the network interface card that the computer is using, or your switch is using, or your system is using, this will result in performance degradation, poor performance. This will result to poor performance degradation when your speed or duplex do not match with your network interface card build up. If it doesn't match, there will be a lot of issues. Is that okay? So, and when there's poor degradation due to collisions or packet drops, so there will be a lot of collisions of packet, and there will be a lot of packet lost. A lot of packet will be dropped somewhere along the line due to collisions and due to poor performance degradation. So there must be a coherence between the speed of your system, of your switches, and that of the network interface card. Okay, now let's move on. Now let's talk about the messages, what you get and what they interpret, what they stand to tell you. When a network device is connected to an available port and the physical link is successful, when you take a network device and is connected to an available port and all the physical link is successful, the messages are displayed on the switch cursor. You're going to see some message that will pop up, right? When the connection is successful, when your configuration is successful, your messages will be displayed on switch cursor. Now, some of these messages we're going to look at. An example of message display is provided for the gigabit interface 0/5, indicating that the interface has successfully linked or has successfully linked with an active network device. So you know previously it was not linked. Okay, it was previously this interface 0/5 was not linked. So when you decide to connect it, a message will pop up like what you see here. Okay, link up 3 up down interface gigabit Ethernet 0/5 change status to up. You see this message change status to up is an indication that you've connected the gigabit fast Ethernet interface 0/5. Remember previously, if you look, previously it was not connected. You see, it was not connected previously. It was not connected, and the mode, fiber mode, was unknown. So now, if we run to connect it, run a command to connect it, is change the status up. So this shows that it's connected now, it's running and it's connected. And then if you run another command, we've talked about commands on how to configure interfaces on switch in the previous sections. So let's say you run one of the commands again. You see this one showing line protocol on interface gigabit fast Ethernet 5 has changed state to up, meaning it has changed to up. It's working now. Okay, it's working, it's no longer down. These are the messages that you get when you run show commands, or when you run commands, or you configure commands on the interfaces. So you get all these type of messages. So this is what we mean by messages on there, and on switch configurations and troubleshooting. Now let's still on troubleshooting. A switch is an OSI layer 2 device. Routers are layer 3 devices. Switch are layer 2 device, and they operate by storing and forwarding the MAC addresses. That's how switch operate. Switch operate by storing MAC addresses and also by forwarding MAC addresses when need be. Switches operate by storing MAC addresses and by forwarding these MAC addresses when they need to. Okay. Also, a switch is generally services more directly connected to network devices than a router. They basically do work that are directly connected to network devices than router. Routers are like gateways to other networks. Switches deals with network devices. Okay, switches work with network devices that are connected together. That's what switch do, like computers, like access points, like IP phones. Okay, all of this switch deals directly with all these network devices. Or like the router is dealing with the switch. It's not dealing with not dealing directly with network devices. It's only other network devices, only dealing with the switch and the gateway to the other LANs, no local area network or wide area network. More populated switch ports mean more network clients. So when the ports are super populated, okay, when the switch ports are super populated, what it means is that there is more network clients, okay, which makes troubleshooting more difficult because there's so many clients on the switch. Okay, like a huge campus network, the switch ports are usually super busy and super populated because every port is usually used most of the time for big campus network. But for small campus or for small office area, not all the ports are used. Maybe one or two is just being used. Okay, but for very large campus, most of the switch ports are used, which means it's busy. So for larger campus, if you want to troubleshoot it, then it's a bigger problem. It's more difficult to do that because every of the ports on the switch is occupied. So you have to troubleshoot every details, every port. Okay, so it's very important to show how to isolate network devices because it's a big one. It's a big network this time if all the ports are being engaged. Okay, now let's still on troubleshooting. It's very useful to be able to tell which switch port a particular network device is connected to. Easy to tell. Now on Cisco switches, the switch command show MAC address table helps us to know which switch or which switch port we were looking for or we are troubleshooting. So on Cisco switches, the switch command show MAC address table or the command show MAC address table helps in displays which switch and which LAN, all of this, or port, which switch port we are talking about or we are looking for. On the newer switches can be used, newer switches can be used to display the MAC address table of the switch as shown below. For example, what we're trying to say here is that if you want to know about the switch port, then you run a show MAC address table command. You run a show MAC address table. So how? By typing switch A hashtag show MAC address table. That's all. You run this command and you will get this display. run this command switch A hashtag show MAC address table. So when you do that, it shows you the VLAN to show you all the VLANs. The MAC address, you display all the MAC address type, if it's static or dynamic. You see, this one is static, dynamic. The ports are CPUs, etc. CPU, so all the ports. Okay? So if you want to know about the switch ports, just run the switch A show hashtag show MAC address table. Is that okay? That's another way of troubleshooting about the switch port. Now, a network administrator can use this command to map a network device by its MAC address to switch port. So, as a network administrator, you can use this command to map any network device by its MAC address, right? By using its MAC address to the switch port. Okay? Then when a device moves from one switch port to another, the switch relents. When any device on the network moves from one switch port to another switch port, the switch relents of the MAC address of the new location. So when your device moves from one switch port to another switch port on the network, the switch will relent, right? The MAC address. The device will relent the MAC address of the new location, right? Okay. I think we mentioned this previously. Not this section, but one of the previous sections. Now the switch deletes its old MAC entries and then updates its database with the new MAC entry mapping, because the device moved to another location and is accessing a new MAC address. So the old one will delete from the database and the new one will be relent. Is that okay? Now there's another command for troubleshooting called the showed version. This one is for uptime. And uptime is to see, when sometimes after running switches, the problem still continue. After running all the commands that we've talked about, and still the switch is still not doing well, then you have to run the uptime. The uptime shows if the switch is rebooting, or if the system is rebooting, the network is rebooting, or reconfigure, rebooting, recopy, whatever terminology you want to use. So this command is super important. Always good to do the show version. The show version command help us to, or show us the uptime of the whole switch, the uptime for the entire switch. So a common task for network technicians to verify the uptime for a switch. You have to always verify the uptime. This will help identify potential problems with switches that might be intermittently resetting. So when your switch is intermittently or continuously resetting, you check the uptime. The uptime will show you if your switch is rebooting continuously. So if you're a network administrator or a network technician, you should know how to run the show version. This show version command helps to show us the uptime of a switch. Now the command for viewing the switch uptime is called the switch hashtag show version. This is the command. As a technician of a network technician or administrator, you should know this. How to run a switch hashtag. If it's switch A, you say switch A hashtag show version. Now the reason to check the uptime is to see if the switch has been rebooting. This is a common problem with switch. They reboot continuously sometimes. Okay, not all the times. They reboot, So when they reboot it, they will not perform optimally. So you need to check if it's rebooting. Okay? So rebooting problems can be due to power fluctuations. When there is your power not stable. In places where the voltage is not stable, we use stabilizers. In places where voltage supply to your system is not stable, we use stabilizers, okay, to keep the voltage at one value. Okay, rebooting in switches happens to often where you have voltage or power fluctuations that is being supplied to a switch. So, and you will know, so your switch will not be performing optimally. And as a network technician or administrator, you need to know in order to fix or troubleshoot a switch, you should be able to run what we call the switch hashtag show version command. This will run the uptime for us and show us if the switch is rebooting. And when that happens, the switch will not be able to perform well. So when you see this, then you're able to fix the problem. You will see the switch problem and fix it and restart the system. So this will help to solve the problem. So this is all we have for this section. Thank you for joining our class. And our next chapter will be chapter 9. We are done with chapter 8. Chapter 8 is in 8 sections. Part 1, part 2, part 3, part 4, part 5, part 6. So this is the last part of chapter 8. So we see again in chapter 9. Okay. Thank you.